Hello everyone, myself is Varun studying in Sri Venkateshwara College of Engineering for Sun. Today in this video I am going to discuss about outer join in relational algebra. Introduction to outer join in relational algebra. An outer join is a type of joint operation in relational algebra that retains unmatched rows from one or both of the tables being joined. It allows us to combine rows from two tables based on a related column while also including rows that do not have a match in the other table. Outer joins are useful for including all data from one table even if there is no corresponding data in the other table. Types of outer joins. There are three main types of outer joins in relational algebra: left outer joint, right outer joint, and full outer joint. In left outer joint, all rows from the left tables are included along with matching rows from the right table. Unmatched rows from the right table are filled with null values. In a right outer joint, all rows from the right table are included along with the matching rows from the left table. Unmatched rows from the left table are filled with null values. Types of outer joints. In full outer joint, all rows from both tables are included regardless of whether there is a match or not. Unmatched rows are filled with null values. Outer joins are commonly used when working with databases to combine data from multiple tables while preserving all rows. Syntax for outer joints in relational algebra. The syntax for performing an outer joint in relational algebra involves using the joint operation along with the outer keyword. For example, to perform left outer joint between table A and B on a common column C, the syntax would be A join B on A. C is equal to B dot C outer. This syntax specifies that we want to include all rows from table A along with matching rows from table B and fill any unmatched rows with null values. Now let us discuss about an example of left outer joint. Let's consider two tables, employees and departments, where employees contains information about employees and department contains information about the departments. Performing a left outer joint between these tables on the department ID column would result in a table that include all employees along with their respective department information if available. An employee without a corresponding department would have null values in the department columns. Example of right outer joint. Continuing with the same example of employees and department tables, performing a right outer join would include all departments along with the employees assigned to each department. Departments with no assigned employees would have null values in the employees column. This allows us to see all departments, even those without any employees. Limitations of outer joins. One limitation of outer join is the potential for creating large result sets, especially when dealing with the tables a significant number of unmatched rows. Outer join can also include null values into the result set, which may require additional handling in downstream process. Care should be taken when using outer join to ensure that the resulting data is accurate and meaningful. Conclusion. In conclusion, outer joins in relational algebra are a powerful tool for combining data from multiple tables while preserving all rows, including unmatched ones. Understanding the different types of outer joints and their syntax is essential for effectively utilized them in database operation. By leveraging outer joints, analytics and database developers can create comprehensive views of data that encompass all relevant information from multiple sources.